Okay, we are on section 8.9, factoring perfect square trinomials. So for perfect square trinomial, the first and the last, the A and the C, have to be perfect squares. Any variable that has an even exponent is a perfect square. 64 is also a perfect square. It's 8 times 8. And if this times 2 equals this, then it is perfect square trinomial. That's 8m times 2 is 16m. So this is the final answer. This one here, this is a perfect square. If it's minus right here, it's going to be minus. This is a perfect square. It's 1. This times 2 is 6x. So this is correct, and we need that little square there. The square root of 4y squared is 2y. Square root of 25 is 5, and we put a minus there. 2y times 5 is 10y times 2 is 20y, so that works with a square there. Square root of 16p squared is 4p. It's a plus 1. The square root of 9 is 3. 4p plus times 3 is 12p times 2 is 24p. So that also works. Put our square sign there. This one we have to put into standard form first. So add 49 to both sides. So we get 4k squared minus 28k plus 49. This is going to be a minus. Square root of 4k squared is 2k. The square root of 49 is 7. 2k times 7 is 14k times 2 is 28k, so that works with the squared sign. This one, 49k squared is perfect square. It's 7k. It would be a minus. And the square root of 16 is 4. 7 times 4 is 28k, times 2 is 56k. So that does work as well. And we just put a square in that, and that's the answer. Okay, we're going to factor these, and these could be multiple different ways. We're just going to take a look at them. So here, the first thing we do is take out a greatest common factor, and 3 is a greatest common factor. We're left with p squared minus 49 when we divide by 3. This is a perfect square, this is a perfect square, and it's subtraction. So it's going to be 3 times p plus 7, p minus 7. Difference of perfect squares after we took out the greatest common factor. This has a greatest common factor. It is 3. So we take out 3, we're left with 4h squared minus 20h plus 25. We have a trinomial. This is a perfect square, and this is the perfect square. I want to put that 3 down also. Square root of that is 2h. It'd be a minus because of that. The square root of that is 5. 2h times 5 is 10h times 2 is 20h. So this works as a perfect square trinomial, and we have to have that 3 with it that we took out at the beginning. This one has a 2. Greatest common factor. So when I take the 2 out, I'm left with 25q squared minus 30q plus 9. These are both perfect squares. I'm going to put it here. They'd be minus because that minus, and I'm going to put the 2 with it also. So 5q minus 3. 5q times 3 is 15q times 2 is 30q. So that is correct. That was a perfect square trinomial after we took out the greatest common factor of 2. This one has a greatest common factor of 2t. They all contain a 2. So when I take out 2t, I'm left with 3t squared minus 7t minus 4 without a t. These are not perfect squares, but we may be able to factor one of the old-fashioned ways. So it needs to multiply to be negative 12, and it needs to add to be negative 7. They are going to have different signs because that's negative, and the larger one will be negative. So negative 12, no, negative, yeah. Negative 12, we have 6 and 2. That would be negative 4. We need negative 7. 4 and 3, that would be negative 1. And negative 12 and negative positive 1, would be negative 11. So we never came up with 7. So this is done. It's not prime because we were able to take the 2t out. But the final answer is this, 2t times 3t squared plus 7t minus 4. This one, taking out the greatest common factor of 6, we're left with d squared minus 3. This is not a difference of perfect squares. That's not a perfect square, so we're done. All we can do is take out that factor, that greatest common factor. Okay, here we have a common factor of 3, actually 3b. So it's 3b times 5b minus 8f. That cannot go down any further, so we're done. Have a great day.